Hello, welcome to Ekidel. My name is Justice Umwaka. I am your instructor. Today, we will be learning how to design a building structurally, and the software that we'll be using is Prota Structure. So by the end of this lesson, you will be able to design any concrete building structurally using the software Prota Structure. Okay, but before we can go to Prota Structure to perform our structural design, we will have to perform our structural framing and also position our column and also panel this ground floor plan here in AutoCAD. Then we can now export this ground floor plan into ProtaStructure and begin our structural design with ProtaStructure. Okay, now looking at this right now, you can see that this is a ground floor and this is a first floor. And this is the plan that we have just here. The link, I will drop this link to this plan directly on my description so that you can download it from that place. Although this plan will be for a donation, so just to support this this YouTube channel. So it will cost you just $2 to get this plan, and then you can use it to perform your structural design. But you can also use your own building plan to and just follow the steps and perform the building plan. But if you want to flow very well, you can just download this plan and then you can flow very well with me. But I'm going to show you all the steps on how you can perform perfectly a structural design from start to finish. Okay, now the first thing you will do right now, once you're given a once you're given a building plan to perform a structural design, the first thing you do is to identify all the elements and features on the building plan. So right now, this is the building plan given to us by the building architect for us to perform our structural design. So right now, the first thing I'll do is to copy this plan. I will not want to make any structural framing on this original plan, so I'll just copy this one out and then begin to remove the features which I do not need. Since we are trying to perform a structural framing, so first thing I'll do right now is to remove all the features, which is all these features that you see here, all these bedroom, bed, and all that. So you just take them off and dimensions, and then just leave the walls and the windows so I can know where there is opening. So I will take every other thing. Let me just undo. I will leave the test. I will leave this test and just take off this everything here off. So you have seen how I'm taking them off so that I'm preparing this building plan now for a structural framing. So I'll take everything which are not necessary out. As you can see what I'm taking off here, which are all these elements. As you can see them here. And also take off these, they're not necessary. I'll take them off, and also this shower and also this WC. I'll take them all from the structural framing plan, which is called a GA plan. I'll also take this off because this is not a column. This is just a a fancy like a cladding below the column. Why this circular theme here is a fancy column, so we don't take that off. We also remove this column basis here. It's not important structurally. We only leave the column, which is this green circular that is here. So we take this off. So leave this only. Also, the same thing again. We do the same thing on this first floor plan. Remove everything which is not important, and then leave only the things which are important. Also, we do the same thing here. Take this off, and also take this off, and then take this off, and then take this off also, and this off also. Okay, so there we take this off and this off. Now, if you have not subscribed to my channel Ekidel, I would say you should do that just now so you don't miss most of my amazing videos, which I'll be performing steel design, another story, super story, and also building designs. Okay, so right now, once you have finished taking off the features which you do not need, the first thing you do right now before you can export this building plan into ProtaStructure to perform your structural design or to perform any kind of building design structurally, the first thing you do is to create your axis and also create your grid. So we are going to click on this layer to create two names, call it grid line, or call it grid, and also a layer again, call it column. So we are going to create a new layer and call this layer grid. Call it grid. And then we are going to choose the color. Let me just choose yellow for my color. I'll choose yellow for my color of the grid line. And I will choose the line type as dash line or continuous line. But I want to use dash line, and I'll say enter. And I'll choose my line width. I'll just say 0.13, and I'll click on this OK. Then now I'll go now to also create another layer and call it column. So I'll click on this and call this layer column. And then I'll just choose the color. I want to use green for my color. I'll just click here and let me use this green and click on green. Okay. And then I'll leave this place at continuous. And then I'll choose my line thickness. I'll just use 0.53 as my line thickness, column thickness, and then I'll click on close. So right now, the next thing I'll do right now is to place my grid line on each of these walls. As you can see it here, this is a wall, and the size of this wall is 225 millimeter, as you can see it here. So the size of this wall is 225 millimeter, which is also equivalent to 9 inches. So right now, what I'll do right now is to create a grid line using my XL as my construction line. So I'll use XL, I'll press enter, and I'll type V for vertical, I'll press enter. Then now I'll have to place this grid line at the midpoint of this wall. So I'll just, now the line width of this is very big. So I'll just do LT scale, and then I'll just type 50 and then enter. Okay, so right now we can see it perfectly. Oh, let me type 20 to make it okay. This is okay. So next thing again, right now I've created my vertical line. So I'll just do again XL vertical to create all my vertical, to create this axis or grid line on all my vertical walls. So I'll just place those values on my vertical walls. I'll place the grid lines on each vertical walls right now, as you can see what I'm doing. Then also, and if you can see, I am working this grid line on my ground floor, not on the first floor. So you have to do your structural framing on the ground floor and not on the first floor, because it is the ground floor that will carry the first floor. Okay, so right now again, I will now, let me reduce this again, LTSK, and make it 2. Okay, so right now I will now start placing my horizontal line, which I will now use XL, and I'll press H, enter, and I'll begin to place my horizontal grid lines. As you can see what I'm doing right now, at the midpoint of every wall, you place your horizontal grid line. Now you can see that we have established a point of column. At this point now, we can now insert a column. So you also create all other grid lines at the midpoint of every wall, as I'm doing right now. So you can see what I'm doing and dividing the wall into two and placing the grid line at the midpoint of that wall. Okay, we go again to do the same thing for this one. Now, if you cannot find the midpoint of this, you just do this the way, click on line and then click on this point, click on this point, and then XL horizontal, just type and this, and then remove this immediately. Now you can see, then again right now we'll do again to divide this grid, this wall, and to place our grid line at the midpoint. So do H and then we'll place this right now. Now this is an inclined wall, you can see right here. So to place this angle, this axis on this line, I'll just, knowing that this grid line, this midpoint, this wall has a thickness of 225 millimeter. So I'll just offset the half of 225, which is 112.5, and then I'll just offset this one, and then I'll use XL, which is construction line, enter, and I'll click on this first point and click on this last point just here, and I'll immediately have my grid line at the midpoint of that wall. Then I'll just remove this immediately and then deselect this and deselect this to just delete this one inside here. Okay, so right now you can see how we have created this grid line right now on this inclined wall. Okay, so right now the whole idea is to make sure that all your walls have a vertical grid line and also a horizontal grid line. So there is no grid line on this wall, so I'll just create a horizontal grid line on that wall. I'll say XL and I'll put that wall there, and I'll also check again if I've placed horizontal grid line on every wall. Okay, this is all okay for me. So right now what I'll do right now is to now let me move this wall, this first floor plan out of this place and keep it here. And then also I move this elevation out of this place and keep it here. Okay, so right now I am left with this alone, and I'll just remove this border. And right now I am left this alone. So right now I'll just create a rectangle in just create it at any range that you want. This is just to trim off this extension line. So I'll just trim this off right now. You can see what I'm doing. Can trim this off right now and trim this off. And also I trim this off right now. Okay, I will now remove this one right now. You can see what we have just achieved just now. So it is time now for us now to start creating our columns, to start inserting our columns. Now to insert the columns right now, you go to layer. Now, if you see, we are drawing this line without layer. You can see that this line was meant to be a grid layer, but right now it is 0, 1. So I'll just select all these grid right now. Select all these grid which we created, and then go here to change it to grid. I was meant to use this grid name to this grid layer to draw my grid line. Else, this grid will not be exported to ProtaStructure. Now again, right now, we go to activate our column grid. Okay, this place must be by layer, here must be by layer, and here too must be by layer. Then right now, we want to create our column. And knowing that the wall has a wall thickness of 225 by 225 millimeter, so I'll just click on this rectangle to create a column of 225. I'll use the word comma by 225 and I'll press enter. So if you measure this column right now, you can see that this column has a dimension of 225, as you can see there, by 225, as you can see it here. You can see. So right now, we can now move this right now using the center point right now, move it to this point of center. I can see that we have inserted our first column just now. So right now, what we are planning to do right now, we are performing the structural framing and column position. So we have established our first column position. Minding these circular columns here, these circular columns are just like a fancy column that came with a plan. So they are meant to be there. You can see right now from this front view, you can see that these circular columns are for the building beautification. So you're meant to leave it and not to remove it. So right now, what we are trying to insert now is the structural columns, which will withstand the load of this building right now. So right now, we have inserted our first column, which is at this point. Now also we copy the column again now to insert. Now this column position depends solely on you. Depends solely on you. But I will advise that your column to column position should not be more than 6 meters. What do I mean by that? What I mean is that your column to column, like now, if you can see right now, we have a column here and we have a column here. So the distance from this column to the next column should not be more than 6 meters for a residential building. You can see that. So this is 3.45 meters, so which is okay for me. So right now, I'll also copy this again. And since this is a staircase, it is always good to place column at the edges of your staircase. So I have a column here and I have a column here. So I go again, there's a column here, and there is a fancy column here which came with the plan. As you can see it here, horizontal, a circular column. So right now again, we go again right now to place our column at this point, and also we have a column here already at the ground floor, so it is also there, which is at the back of, which is just like this at the back view. So we go again to place our column at this point. This column will be able to carry this cantilever because you can see that we have a cantilever of 900. This is a cantilever of 900. That is why you can see that this is the ground floor plan and this is the first floor plan here. You can see that this is a cantilever. You can see that this is a cantilever on the first floor, and also on the staircase there is also a cantilever on the first floor. That is why you can see the cantilever line here also. This pink line here means a cantilever line for this plan. Okay, so again we go again right now to place our column at this point. And then again, we go again right now to place our column. And we will place a column here. I'll show you how to place a column on the point of intersection of a vertical wall and an inclined wall. Okay, but for now first, let's place a column at this point. And then we go again right now. This is coming here. We will now place a column at this point. And also we want a column to be placed not at this point, but we can place a column at this point let us place one column first at this point. Now, this column position depends solely on you. It is your right as it is your right as a structural engineer to know where you want to place your column so that it can be able to carry the structure. So I'll place my column here right now. So looking at this now, this column, these two columns seems to be very close. So what I'll do right now, I'm going to remove this column and transfer this column to this point. But first, we will have to create a grid line here because you can see that there is no grid line here. So we have to create a grid line for this one. So I'll just divide this by 2 and then copy one of this grid line and then just trace it up here, copy from this point and bring it down here, and then remove this point, this line of division, and then I'll just move this column from this point to this point. Now, if you want this building plan, just click on the link below and download it, and then you can use it for your lesson and for your practice. Okay, so let's just check the distance between these two columns from this point. Like I said, the distance between two columns must not be more than 6 meters. So this is just 3.7 meters, which is okay. Okay, right now. So right now, let us check the distance between this column and this column. It is very far, which is 7.05 meters. So right now we are going to insert a column at this point and also at this point. So let's just copy this column right now from the center here and move it to and copy it down to this place. And then also we need a column at the point here. So right now I'll show you how. Let me just put the column here. Now I'll show you how to place a column at an inclined wall intersection. So to place a column, you just click on this point and then place a column directly on this face so that this inclined wall will be able to flush on this point and also this also flush on this point. So right now we will also do the same thing here. So I'll just do right now, copy this column right now from this point, and then copy it from this point, and then just place it here first. And then I will now move this right now, moving from this point to this longer edge. You can see what we have just done right now. Okay, so the next thing right now we'll do right now, you can see that we have this column. We now have this column with this grid and this grid, but we have to create a vertical grid on for this right now. So we go right now and click on grid to activate our grid line, and then click on concession line, which is this. You can see it right now, and click on this and then type vertical and place it here. But we want to shorten this right now, so I'll use rectangle to shorten this, to just trim off this line, or let me just use this line and then take a reference point here from here, and then trim off this extension line here, which is, and then remove this immediately. And then also I will also trim off this line from this point, or from this point I'll trim off this line from this point, this excessive extension line which has no end. So I'll just trim it off and then remove this immediately. So you can now see what we have gotten. The same thing will happen here. Since this has a vertical wall, a vertical grid line, this will also have a horizontal grid line. So I will just go right now to create a concession line XL horizontal at the midpoint of this column. And also I'll just trim off this line from this point. Click on this, type TTR, which is trim, and trim off this point right now. Now, if you don't know AutoCAD, I would say you should just check in most of our videos. We have also done video on how to use AutoCAD software. So I will also trim off this right now, and then go this right now and trim off this right now. Okay, so right now we take this off by erase. So you can now see what we have achieved. I would like to trim off this line. It is too long, this inclined line. I'll just trim off from this base here, from this point, and then take this off right now. Okay, so right, this is what I'll do the same thing for here right now, and just take this off right now. Do this and then TR minus, and then take this off right now and do okay. So right now you can see what we have. I will also shift this up right now. Okay, so right now you can see what we have just achieved. We now have our column. Let me check the distance between this column and this column right now. This is 5.1 meter. If it is okay for you, like I said, it should not be more than 6 meters. So since this is between that range, which is 5.1, you can see there 5.175. So it is within the range of 6 meters. So I would don't have you don't have to place any other column here, except you just want to waste the client's money, because this column and this column for a residential building can be able to carry the 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 load on this area. So right now we do the same thing. We also check for the internal distance. So you just check for all your distance column to column to know, to be sure that no one is more than 6 meters. You can see that right now. We also do the same thing to check for this, and then this also. This is 3.225, so that's okay. Now, once you're done with that right now, the next thing you do right now is your paneling. What is paneling right now? Paneling simply means how you want your beam to run and how you want your slab to be to like panel. Now, looking at this right now, you can see that we have from this distance to this distance is 5.1175, and also this distance to this distance, let me just check the distance, is 3.45. So this bay, this is a panel from this point to this point. Like as you can see right now, this is a panel. As you can see, this region here is a panel, and from a structure and from British Code of Practice and also American Code of Practice and also Indian Code of Practice, it is advised that the area of a bay should not be more than 30-meter square area. So what do I mean by that? If you multiply the length by the width, so if you multiply this length now, which is 5.175, multiplied by 3.475, so this length by this width multiplied should not be more than 30 meters square area. So if this no more than that, then you are good to go to use that as a panel or as a bay. But if it is more than that, it is advisable to provide an internal beam to be able to cut or to divide this panel into two. So right now, if we now multiply this by this, if I honor my calculator right now and then do 5.175 multiplied by 3.3.45, you can see that now we have 17.85. So this is less than 30 meter square area. So with that now we can use this place as one panel. So with this right now, I'll just take this off and take this off. I don't need this right now as my beam again, so I'll just take this off right now and use this place as one panel. So I'll take this off and also take this door off, and then with that right now I'll just join these broken lines together, because I have now placed one of my beams. So you can see that. Also join this together right now and this together right now, and then we also extend this line. This we also extend this beam. Now this is now a beam because right now we have formed our panel, so our beam now is now surrounding this panel, as you can see right now. So this is now, so we can now from this take off this right now. We don't need this again. We take off this because this is called a structural framing or a general arrangement drawing. So this is now one panel, as you can see it right now. So the same thing goes for this place right now. We take off this door right now and then just extend this right now to this place and to this place and remove this right now. Okay, you can see what we have gotten right now. So the same thing, we remove this, remove this also, take this off, and then if you measure this, you measure this bay right now from this point to this point. As we all know that this bay will not be will be less than 30 meters square area. You can see right now. So if we do this times this will give us around 5 to 6 meters square area. So this is okay for a bay. Or and also we also, if you also check this right now, you can see that this is less than this bay. So this is also one bay. So we can also remove this door right now and then just extend or just create our beam here. We create our beam line here and then just change the match properties to this and to this. Okay, so right now you can see that this is now one panel and this is another panel and this is another panel. Most of you can be saying that why not I use this place as one full panel to remove this beam. Yes, it is my choice. If you want to use here as one panel, it is okay, but for me I want to keep this beam right here because this is a veranda, and you can see that this is a veranda on the plan here. You can see that this is a veranda and this is a main wall line holding this kitchen. So but if you also use that as one panel, it is not bad, or but if you also separate it, it is also good. Okay, so next right now to do right now is to remove this right now and also um match properties for this, because this is now the staircase hall. This is a staircase hall. Now staircase hall is usually done using void symbol. So I'll just cause this staircase area as using void symbol. I'll cause it X this way, and I'll just match properties using this one, and I'll match to this and match to this, and I'll have to remove this staircase here because we don't need that in ProtaStructure for design. After, we will have to use another software to design. We will use a software called KCSoft to design the staircase, and I'll also show you that software when it comes to staircase design. Okay, so right now, this is now our staircase hall. So we have our slab here, we have our slab here, but on this place there will be no slab here because this is a staircase hall. But at the back of the staircase we have a cantilever slab which we will take which we will take into consideration in ProtaStructure software. And also on this place also we have a cantilever. We also have a cantilever. We also have a cantilever here, which we'll also take into consideration when we go to ProtaStructure for the design of this cantilever and for this building also. So right now again, I will also remove this because I want to take this right now as one panel, as you can see right now. I want to use this right now as one panel. So let me just join this because there is a change of line here. I'll just join this right now together. Okay, let me just extend or join this here. Okay, so right now, I want to use here right now as one panel, and also I want to use here again as one panel. So I'll just remove this wall right now and then extend this this beam or this wall to use this place as my beam, and then this is now one panel. So I'll just remove this right now and remove them. And also the same thing happens here right now. I will remove this door, and then I'll just create let me use color 0, and then I'll just create a just a beam which does not have any wall load on top of it. So I'll just leave it. I will not go and match properties like this. I will not go and match it like this because because I when we go to our design, all these ones that have thick lines, we is the walls that have is the beams that have wall load on it. So we will have to we will have to impute wall load on it. So right now this is what we have gotten. So I want to place if you can see this distance, let's take this distance right now from this point down to this point. This is 5 points something. I don't want to use this place as a whole. I want to create I want to insert a column at the center of this staircase. So what I'll do right now is just to offset this grid line or copy it down to the center of the staircase, which is found here, and then I'll just copy one of this column and place it at the center of this staircase. Like I said before, column position depends solely on you. So no one can advise you on how to place your column position, but if only you are not interfering with the with some of the elements at which are found in the ground floor plan, and also if you maintain all the rules in column position and also in structural framing, I tell you that your building will be perfectly designed. So that's why you will see how we design this building perfectly. So right now, I now have a column that separates this staircase. You can see right now because this is a void, and this void, when you have a void, it is there are some loads that act in a void, which I will explain more and more in most of my videos. Okay, so right now we will also okay, we will now remove this right now because we now have this right now as one panel, and we will remove this. We don't need this. So we have it right now as one panel, and also there is a small slab here which we also take into consideration, as you can see it here right now. So what I will do right now, this is also as one panel. So we remove this door and then extend this line right now, extend this also, and then remove this right now. Okay, so then we will now change this right. Let me just change this right now to P1, which means panel 1. So I'll just copy this right now and place here and say P1. And then I will, let me just say, move this right now, move this to this point, and then copy this right now, and then place this here and call it P2, and let me just call it P2. Okay, and then I'll also move this right now. This is just to make you understand the number of panels that we have right here on our building model. So we put this tree. Now this process you're doing right now is called structural framing, or it is called GA drawing. Okay, So with the GA drawing simply means general arrangement drawing. So this is panel 4, and then we copy this right now to locate our panel 5. So this is our panel 5, and these are panel 6. So let's just rename this right now and call this panel 5, and also this also call it panel 6. We call this panel 6. Okay, so right now we go again right now, copy this right now and call this panel 7. Okay, the reason why I'm placing this, because when we go to our Prota structure, it is this name that will guide us where we have our slab. Okay, because this is a staircase which must not have a slab. Okay, so we also copy this right now and place on this place, this point here, and call it panel 4. So we go there right now and call this panel 4, or panel 8, sorry. And then we copy this right now and call and go to this place. There is a small slab here, and we have just call here panel 9. Okay, panel 9. And then the reason why I'm using here as a pin is because this is an inclined wall. So if I can possibly take this right now and allow my beam to run to join to this place and then go this way. But this is an inclined wall, which most times inclined wall always crack. So I want to place a beam here to be able to withstand, because if you can see also, we have this inclined wall. Okay, there is no inclined wall at the top here. So this inclined wall is only at the bottom. Okay, so with this right now, we can possibly remove this inclined wall right now and put this wall on and put this beam on this face. But if you look at the plan that we have here, you can see what the plan is right now. You can see this cantilever that we have here, which is this cantilever that we have here, which we have here. You can see this right now. This is the cantilever, and this is also the cantilever, as you can see right now. And on this plate, this is the cantilever, and this is also the cantilever that we have here. Okay, so right now we also copy this right now and then go to this place and put this panel. This is the last one was panel 9, so this is panel 10. And then we copy this also right now and go to this point right now and put here panel. Let me just place it here and put here panel 11. Okay, panel 11. Okay, let me just put this inside this place. I'll just rotate and then do like this and then rotate it and then, sorry. Okay, I can see it this way and just keep it here panel 11. Okay, so right now you can see that we have total structurally three, 11 panels and with just one slab, which is the void right here. So right now, this is what they call structural framing. You have framed this building perfectly. You have framed your structure. You can see there. This is showing you your beam line, how your beams will run, and also your column position. So right now, we will have to export this right now to ProtaStructure. Now, to export this floor plan to ProtaStructure, you can see that we have many plans right here, but what we want to export is only this plan that we have done our structural framing. But before we do that right now, you should know that we have a first floor plan. So what we'll do right now is to make a superimpose, these columns onto this first floor plan to see if the both plans are equal, or to see if there is any column coming out on empty space, so that we can take note of that column, so that when we go to perform our structural design, we can find a way to remove that column on from empty space where it is appearing. Okay, so right now, what I'll do right now, I will click on one of these columns. Right click and I'll click on this place called select similar. So right now you can see that all the columns have been selected similarly. You can see that all the columns have been selected. So I'll now type CP, which is copy, and I'll click enter. Now right now it is always good to copy. It is always good to find a perfect reference point for where you can copy and then paste on the first floor plan. Now, reference points are always good on around the staircase, because staircase position does not change. So right now, the reference point for this that is perfect is this point right here, because this point is the same point as this point, as you can see right now. So we will now copy from this point right here, from this point directly, and then go to this same point and place it directly here. Now, if we place this point right now, you can see that all our columns are hidden inside the walls. None of the columns is like coming out like this. So the reason why we do that is to see if we see any column coming out on empty space, because if you see any kind of column like this, I mean, it is not good. So you will have to hide that column so that it will not come out on the building, which will cause obstruction for the people using the building. So right now you can see that there is no issue. All our columns are being hidden inside the wall, both both on the ground floor plan and on the first floor plan. You can see that. So with this right now, our plan is perfectly okay. So with this right now, we can now export this plan alone into ProtaStructure and begin our structural design. To, so export this right now to ProtaStructure right now, what we'll do is to select only this ground floor plan that we did our general element plan or drawing, and then we will now click on W, which is to save just this plan separately. So we click on W and we type W and press enter. Now, once you type enter, a dialog box will appear showing us where we want to save this plan alone. So we will have to now click on this point. You can see this point that have three dots. So click on this point right here. Now it's asking us where we want to save this drawing right here. So I'll click to choose on desktop. So once I click on desktop right now, I'll now have to change my file name. So I'll just save this and call it Aki plan. Okay, so I'll call this Aki plan, or I'll just use the client's name. I'll say Mr. John's building, Mr. John's building, building. Okay, Mr. John's building. And then now once you type the name, the main thing right now for you to do is to choose the file type. If if you click on this place, this file type must be on DSF. Now for this plan to be exported to ProtaStructure, it all depends on what you choose here. Now ProtaStructure only accept file from AutoCAD when it is being saved on DSF format and not DWG format. If your drawing is being saved on DSF, then when you export this drawing to AutoCAD, it will now show the elements that you have inserted here, which is the column and the grid. It will show on ProtaStructure as axis and as a column member. So right now, what to do right now is to choose any of these DSF and save this our drawing. So right now, I'll just choose any one. Let me just choose DSF 18. But if you don't have this, you can choose DSF 2000. Anyone you have. Okay, let me just choose DSF 2000. So I'll just choose this right now. The main thing is that your file must be saved on DSF format. So I'll now click on, you can see our name here, Mr. John's building. I'll now click on save and then click on OK. Now, right now, if we now minimize right now and go to, if we go and check and open to check that our plan right now on desktop, you can see the plan here on desktop, Mr. John's building, which is DSF. Where is it right now? It should be on DSF format. DSF, let me choose DSF format. Okay, you can see our file here, Mr. John's building. You can see it here. So right now, this file is now on desktop. So we can now just cancel. I just want to show you where you can find your plan. So with that right now, this is how to perform a structural framing, to prepare your building plan for a structural design if you want to use ProtaStructure or even most advanced design software. So you must perform a structural framing. Even if you want to perform your design manually, you must have to perform this stage called structural framing, which you have to position your column and also note where you want to place your slab and how you want your beams to like run. So this is how to perform your structural framing. Now we are now moving to design stage, which we will now begin our structural design using ProtaStructure software. So I'll stay, you should stay tuned while we now move to design stage using ProtaStructure. Now, if you want this plan, you can see here, if you want this sample of plan, just click on the link below and then download this sample plan and then begin to perform your structural design and also follow me up. Now we also have our link on Facebook. We also have our link on Instagram and also our link on Twitter. I would say that you should follow us on all our social media using the name Ekidel. And if you have not subscribed to this channel, I would say you should subscribe to my channel Ekidel so that you don't miss any of my any of my video upload or any of the update I'm going to show you guys. Okay, so right now we are moving right now to ProtaStructure to perform the structural design. So we are moving to the structural design stage. Okay, so let us go there right now. Thank you.